Hi everybody, hi. Okay, so now we're going to start actually doing calculus good stuff. Okay, on not the last video, the one before, we went over this as using this to find the slope of a tangent line. Remember, it was, we have our Cartesian coordinate system and you have some kind of a function, say like this. Okay. There are infinite number of lines that would hit this at one and only one spot. Okay? The slope of that, that's a tangent line if it hits it at only one point. The slope of that was our instantaneous rate of change. That's just like shorthand for writing it. Remember that delta triangle means change. So instantaneous rate of change. Okay? And we use the limit to get that. That's also called the first derivative. Okay. So we use this, remember, well, if you want to go back to the other video, or you can look on Khan Academy, has the identical lecture that I do for how we got this, but hopefully you're okay with it. So what we're going to do is, first off, I have to give you some shorthand. If we use y, the first derivative is y prime. Okay, this is not a one, it's kind of like a single quotation thing. That's called y prime. If we're calling it f of x, then this would be f prime of x. That's how we denote the first derivative, which gives us our instantaneous rate of change, or our velocity, which is speed with direction. Okay, so that's just the different way to write it. So what we're going to do is we're going to do several of these, and then hopefully you're going to establish a pattern, so that once we get a pattern going, we never have to do this again, because that would be great, because this is tedious. Okay, when we had f of x was equal to x squared, this is what we did on the other video. F prime of x, whenever we put it through this limit thing, was equal to 2x. Okay, so let's do some other ones and see, now write them over here and we'll see if we can get that pattern established. Okay, so let's do if f of x is equal to 4x squared. Okay? So what we're going to do is we're going to do f of x plus h, which means replace this x with x plus h. Notice here, you have to be careful about a few things. The 4 is not being squared, only the x. Remember, only applies to what's directly under it. Okay, so we have our limit as h goes to 0 of 4 times x plus h quantity squared. Okay, so you just replace this x with h. Then minus f of x. Well, f of x is given to us. It has to be given to us. So we just subtract that. And then the whole thing is over h. So just like with the other limits, I can't let h equal 0 because of division by 0. So I have to simplify up here and get that h to cancel. That's the goal. Okay, order of operations. I have to square this before I distribute the 4. Remember, this is not x squared plus h squared. It's x plus h times x plus h. These are a pain in the neck. I think they're fantastic, but I think I might be alone. Okay. Limit as h goes to 0. You get really good at foiling those because you do it so often. Okay. So x times x is x squared. Remember, I'm going to put them in alphabetical order so it makes it easier to combine like terms. So x times x is x squared. X times h, I'm going to write as hx. Then h times x is hx. Then h times h is h squared. Then I have my minus 4x squared. Oh, nice, Beth. Okay. This is going to be a hot mess. Okay, so now I would combine these like terms here. Okay, this is going to give me 2hx. And then we'll distribute the 4. So we have our limit as h goes to 0 of 4x squared. Then 4 times 2hx is going to be 8hx. Then 4 times h squared. Then minus 4x squared. Whole thing over h. Okay, this and this are going to cancel with each other. Here's a little hint, okay? Anything that comes after this minus sign here, it's going to cancel. If it doesn't, you've made a mistake. Okay, it's always going to cancel. Okay, so now what we have is we have our limit as h goes to 0 of 8hx plus 4h squared over h. Just like with the other limit problems, remember I want to get this to cancel. So I can take out a greatest common factor of h. Now I could take out a 4h, but it's not going to be of any benefit. I just want that h out of there so I can cancel it. It certainly isn't wrong if you factor out 4h, okay? Just why do extra work if you don't have to? Okay, so now that's going to cancel. And so now that I don't have to worry about division by 0, I am free to let h equal 0. So I have 8x plus 4h. Well, if I let h equal 0, 0 times anything is 0, that's going to be 0, and the whole thing is going to equal 8x. So that tells me when f of x is 4x squared, f prime is 8x. Wish my board were just a tad bigger here, but yeah, we have what we have, right? Okay, so let's try a different function. Let's try f of x is equal to negative 3x squared. Okay, so we're just going to use this. So we have our limit as h goes to 0. And usually at this point, students always say, do I have to write that limit thing for every step? Technically, yes, but am I going to know if you do or not? No, I don't. If I'm doing this problem on my own, like if I'm making up, solution sheet, I don't. Because your calculus gets too big. Okay, so f of x plus h, just replace this with x plus h squared. Then minus f of x is minus this thing. So I have minus negative 3x squared over h. Like always, when you have a negative, you got to be careful. So over here, I'm going to FOIL this first. And it's the same as the previous problem and the one before that. So it's going to be x squared plus 2hx plus h squared. And that negative and a negative is going to give me a positive. Okay, now I can distribute that negative 3. So I have negative 3x squared minus 6hx minus 3h squared plus 3x squared all over h. Okay, this negative 3x squared, this positive 3x squared, they're going to cancel. So remember what I said, whatever comes after this minus sign, it's going to end up canceling whatever term is there. Otherwise, you've made a mistake. Okay, so this gives me the limit as h goes to 0 of negative 6hx minus 3h squared over h. Again, I just want that h to cancel so I don't have to worry about division by 0. I know I could factor out a negative 3h or even a positive 3h, but I'm not going to bother with that. I'm just taking out the h. It's not wrong if you take that out, but okay, so that leaves negative 6x minus 3h over h. Those are going to cancel. So I have my limit as h goes to 0 of negative 6x minus 3h. Okay, now that I don't have to worry about division by 0, I can let h equal 0. 0 times negative 3 is 0, so that whole thing's 0. So the whole thing just equals negative 6x. Okay, so let's add that to our little chart here. When the function is negative 3x squared, the derivative is negative 6x. You might be starting to form a little pattern. Okay. Let's see here. What am I going to do? Okay. What if I have the limit as h goes to 0? Let's say my function is it nothing, it's okay. I didn't just spill markers everywhere. Okay, let's make our function x to the third. Just by changing that, upping that exponent by 1, exponentially longer variable. Okay, so we'll have our limit as h goes to 0. Replace your x with x plus h. Then minus f of x, which is x cubed. Oops, 3 over h. Okay, so now, remember, this is not x cubed plus h cubed. This is x plus h times x plus h times x plus h. I don't care how smart you are, even if you're a computer. The most things you can multiply in one step is one thing times another. So, I'm going to do it this way. X plus h times x plus h squared minus x cubed over h. Okay? This times this would give me that. I know this because we've done this a bunch of times. So we have the limit at, leave our x plus h. And then when I FOIL this binomial, we know it's x squared plus 2hx plus h squared minus x